All right, so we're going to do today the opposite of what we did last time. So I don't know if you even remember what we did last time, but last time we took some logarithmic expressions and we combined them. So does everyone kind of remember that? We had like a log plus a log, and we put them together in one logarithm. And when the logarithms were added, when we stuck them together, do you remember we multiplied?
Yeah.
And when they were subtracted, when we stuck them together, we divided. Well, today, we're going to do exactly the opposite. So we're going to take one logarithm, and we're going to split it up. So, since we're in our notes, back at page 35, problem 2A. There are two parts to this problem, an x and a y. So there's going to be two separate logarithms, ln x, ln y. And then I have to decide what I'm going to put in between them. So what do you think?
Plus.
These guys are being times,
Plus.
so that's going to be a plus. Yep, you got it. That's easy. Okay, what about this one? Log x cubed over y to the fourth.
You have to
So
read.
we're going to have a log x and we're going to have a log y because the problem has two pieces to it. It's going to be a subtraction.
And then 3 and 4.
And a 3 in front of this one, and a 4 in front of this one. Wow, you guys remember. Good, good, good. All right, so let's step back here.
Oh.
How about this one?
Oh, this one.
That's it.
Now, do what you know first. You know it's going to have a log x, and you know it's going to have a log y,
Is it minus?
and it's going to be a minus because divide division, right?
One, and then that one.
Is
Is it a 1/5?
1/5 in front of those.
Hold on,
Because we remember, you do remember, and it's awesome, you're making my day, that a fifth root is a 1/5 power, right? So anytime we have a square root, it's a 1/2 power, a cube root's a 1/3 power, and so on. Since both of these guys are under the radical, that's why they both get the 1/5. When you look at the next problem, you're going to have a log x, and a log y. They're again going to be subtracted,
It's 1/4 log x.
but the 1/4 is only going to go with the x because only the x is under the radical. Now, the next one has two parts. It has a log 100 and a log x. Those are the two parts of this one. They're being added, and there's a 2 in front of this. Now, how do we feel about that, okay? Because this is a little bit tricky. This one's not done. This one's not done. I want you to think about this guy for a second. He is special. He is special. If you were walking down the hallway and you found this laying in the hallway, what would go through your mind?
10 squared.
What does this equal? Well, 10 to the x is 100. This log of 100 is 2. Because 100 is 10 squared. So we have the log base 10 of 10 squared. It is 2. So the final answer is 2 plus 2 log x. Because this is 2. This is 2.
Why don't you write log?
Because the log of 100 is 2.
Oh.
If you type that in on your calculator, log 100, it would say 2. Now, if this number had been 90, then I would be done right here, because the log of 90 is nothing special. But because it's solvable, it's simplifiable, I have to go ahead and do it. Okay, last one.
Log E of 30.
So it's gonna be L, I'm gonna say ln 30,
Plus 3 ln.
and, oh wow, 3 ln E, or, because that's a lot all at once. Well, wait, are we okay with this?
No,
Wait, stop, are we okay so
oh
far?
yeah.
Okay, so we had ln 30, we had ln E, that's a cube, so the 3 came out in front, they're added because this is a times. So we okay with that? Alright, now, Jake, what do you notice?
The ln of E cancels out
Exactly.
because it's a logarithm.
Exactly.
So it's ln.
Yeah. Whenever an ln and an E touch each other, physically touch each other, they cancel. They're inverses of each other. So your final answer is ln 30 plus 3.
Would you care if you just said log E of 30?
No, if you want to say it is log AC of 30, that's fine. All right? Wow, you guys, that is the most amazing you've done all year. So impressive. Good work. Okay, now we're going to go to our calculator, and we're just going to type some things in. Round to the nearest 10,000. Now, I want everybody paying attention because we all have different additions of the calculator, all right? So we're going to do these problems exactly the same in terms of homework, tests, and quizzes. What you do on your own, if you're out evaluating the logarithms on your own, I don't care. But we're all going to use what's called the change of base formula. It's very simple. I know some of your calculators will do this differently. You're going to do it this way. So we have the log base 3 of 4. Remember, when you press the LOG key on your calculator, that is not base 3, it is base 10. So you're not just going to type log 4. That will not be the right answer to this question. However, we can type this in by typing log 4 over log 3. So in other words, we can change any logarithm into a typable logarithm by simply doing the log of that number divided by the log of this number. Now, again, I am fully aware that some of your calculators have other capabilities. I don't care. This takes 2 seconds. This is how we're typing it in, everybody. So, just be careful. When I hit log 4, when I hit log, I get a parentheses. So then I type 4. Close the parentheses, and then divided by log 3. You can close those or leave them open. It doesn't matter because you're done. You're done typing. And did you get 1.2619?
Yep.
Now, 10,000, how many decimal places is 10,000? 4. So that's why I rounded it off like this. Okay? So I'll do one more with you, and then I want you to do the rest on your own. We're going to type in, it's the log base 29 of 3. So it's log 3 over log 29. Kids, if you look at the problem, isn't the 29 kind of underneath in the problem? That's where it goes when you do it. So it's always log that over log this. So that one turned out to be did you get 0.3263?
Yeah.
All right, go ahead and type in the others and we'll run through the answers. If it looks like a decimal point, it is a decimal point.
Always put the numerator in parentheses,
Huh?
Always put the numerator in parentheses.
Has to be. Otherwise the calculator won't divide right. I mean, it does exactly what you tell it to do, so you gotta tell it to do the right thing. All right, C, Jake?
0.8115.
I got 1.2.
Yeah, 1.2322.
Yeah, I got that.
I got 1.2323.
Yeah,
Yeah,
that's
that's
what I got.
what I got.
That's what I got. That's log 11 over log 7. Log 11.
Oh, shoot, I did all.
So Jake, I said, probably when you weren't listening, it's underneath, yeah. See how the 7 is lower? It goes in the bottom.
Sorry.
The low number goes in the bottom. Okay, so D, Lexi, what'd you get for D?
1.7354.
1.7354?
Yeah.
That's what I got. Tyler, what'd you get for E? Yep, negative 2.3532. Negative outputs are fine. It happens, we get those. And F, Mr. Bonds, what'd you get for F?
I haven't done it. 6.49189.
4 decimal places, so 6.4919. 5 and up, we round up. All right, everybody okay? Easy, easy, easy. Okay, now we got a couple word problems here. Leave your calculators out, you're gonna need it. We got a couple word problems here, so. We have a formula for the light intensity in Lake Superior. And I want to know, what is the intensity at a depth of 10 feet? Okay, so what does that mean? What am I gonna do? Plug in 10 for X, because it says a depth of X feet. So I'm just gonna put 10 right there. So log I over 12 equals negative 0.0125 times 10. So negative 0.125. Now, wait, cancel the logs. There's one log. Right? So back up a second. Multiply by inverse. Listen, a couple of days ago, maybe last time, I can't remember, we did a problem that looked like this. Something like this. I don't know. I'm making it up. How did we solve that? Because essentially that's what we have here. We have the log of something equal to a number. What did we do with that? We put a 10 in here, and then we did our loop-de-loop. Because a loop-de-loop is how you get rid of a logarithm. When you loop-de-loop this, the log is gone. So I'm gonna come over here, and that's really the problem here, is I can't, somebody said times by 12. I definitely wanna multiply by 12, but I can't because it's in the middle of this logarithm. So let's loop-de-loop this. 10 to the negative 0.125 equals I over 12. Now can I multiply by 12? So I'm going to take out my calculator and I'm going to multiply 12 times 10 raised, and this is your button that raises, raised to the negative 0.125 power. And hopefully you got 8.9987.
For writing.
You need what? Where's your calculator?
Push the button.
I don't have it, you don't have one, do you?
No, I do have a calculator.
Where is it?
Okay.
Did you leave your phone at home?
No.
Oh, no, no. Your calculator's like your phone, right? It's a necessary part of your existence. These infractions are just gonna add up, Jack. All right, everybody get that? Okay, moral of the story. If you have an equation you're trying to solve, and it involves one logarithm, how can we always get rid of that one logarithm? You do. And then you just have a regular equation to solve. All right, B. Now I have a new equation. Oh, let's just do A. We don't need to do both of these. Let's just do A. Compute the earthquake magnitude, so find R. If A is 250, T is 2, and B is 4.25. Isn't this easy? I'm gonna just plug it in. Now notice, my variable is already solved for. It's over here all by itself, R equals. So I'm just gonna type that in. Just type it in on your calculator. Wow, that's easy. Did you get 6.3469? Does that look okay?
Yeah.
We're not gonna do the second part because it's just too easy. All right, moving on, 3-4, due on Tuesday, or Monday, today's Thursday, right? Yeah,
Yeah.
Monday. So 3-4 is due on Monday. All right, we're starting 3-5, here we go.
Do you have any quiz or test before?
I don't know,
Feeling,
We don't have class
I
on.
don't think I have enough class period.
yeah, we don't have class on Monday.
We don't have class on Monday.
And then is Tuesday a weird schedule or no?
I hope not. I don't
Oh,
know.
yeah, you were.
What would be weird about it?
Math?
I don't know.
We have
Oh,
class?
adoration. Oh. Oh, no,
No,
that's
that's
after.
before
That's
it's-
after. Yeah,
That's
that's a
before
while.
it's
Yeah, I don't think it's.
All
Senior
right,
math?
here we go. 2 to the x equals 8. I'm supposed to be solving this with no calculator. You know what the answer is? 3. I don't need a calculator. 2 to the x is 8. X got to be 3. 2 cubed is 8. Now B adds a little wrinkle. What do you think about this one?
2.
So what am I gonna do first? Divide by 3? Now, some of you just kind of eyeballed it and guessed, and that's fine. But in terms of actually solving it, you're gonna need to get rid of that 3. And it says 4 to the x equals 16. And now we know x is 2. So if you could look at this and say 2, that's fine. But in terms of solving it, we want to divide by that 3. Get that 3 out of there. Now, C is a little bit trickier. Now, you're not far from doing the right thing. So, he's noticed that 4 and 8 are both powers of
That's what I was thinking.
Yeah.
Now, I'm not talking about being divisible by 2. I'm talking about they are literally powers of 2. So 4 is 2 squared, 8 is 2 cubed, and once I have those two bases the same, I can just set the exponents equal to each other and solve. So the key is making the bases the same. And if you're doing this kind of problem without a calculator, you will be able to make the bases the same, okay? Because if I can't, then I need my calculator, and that's the next lesson. All right, but today we're no calculator. All right, so next we've got 3 times 4 to the 2x equals 96. Step 1,
Divide by 3.
divide by 3.
32.
So 4 to the 2x equals 32. Now, I already had 4. 4 is 2 squared. Is 32 2 to a power?
Yes.
Which one?
4.
No,
Fifth?
fifth. Fifth.
Yes.
Now, if you don't have that memorized, if that's fine, you can figure it out, right? 2 times 2 times 2 times 2 until you get to 32. It's 2 to the 5th. Now, this is a multiplication. So 4x equals 5, and x equals 5/4. All right, tell me what are we doing here? Divide by 2.
125.
And what's going to be our common base?
5 to the 5.
5? 5. So 5 to the x over 3, this one's already 5, equals 5 to the what?
Third.
Third? 5 times 5 times 5?
Oh, it's 1.
So x over 3 equals 3,
9.
so x equals 9. See how easy these are? All right, let's try F and G on your own. Did you find a common base for F?
3. Yeah.
3? So you change 9 into 3 squared. And you change 27 into 3 cubed. Now be careful. This right here, this exponent is a distribute. So 2x plus 6 equals 3. Did you get negative 3 halves?
Yeah.
Yep. Yeah.
Does anybody have a question about that? Okay? Now this one, when you divide it by 36, what's that? 9 over 36? Okay. Now normally we don't like fractions, but in this case it's wonderful news because 1/4 is 1/2 squared. So now I have my common base. So it looks like x equals 8. Anybody get that one on your own?
Yeah.
I got a little confused on that one.
Okay, 2 more and we'll go on. H and I.
Divide by 27.
Divide by 27. Okay, that sounds like a good idea. So 1/3 to the
9.
x is going to equal, what is that?
9.
9? Okay. You need a common base. What are you going to use?
1/3. Base 1/3.
You're going to use 1/3 as your base? Okay, you can do that. Absolutely you can. But then this has to be 1/3 to a power then. Negative 2. Very nicely done. Your base could also have been 3, but one of the exponents is going to have to be negative on one side or the other because that's a 1/3 and that's not a 1/3, right? So x equals -2?
Yeah.
Hmm.
Automatically
That's
ignored.
easy. Alright. 1/8. 2 to the x over 5 equals 8. Step 1. Divide by an 1/8, which is the same as
64.
multiplying by 8.
64.
So 2 to the x over 5 equals 64. And now we're right back where we were a minute ago. 2 is gonna have to be my base. So I gotta figure out 2 to the what? 6? Right? So it looks like x over 5 equals 6 and x equals 30. Alright, we did that quickly. I'm gonna let's go ahead and go.
There we go.
Don't tell on me, I'm letting you out early.
Well.
Although it's all on video, so I guess they can get me if they want.